Yo, Chuck.
This video is going to be on permutations and more specifically how to make a function that will give me every possible permutation of a set of data. So if I had a numbers like 1, 2, and 3, for instance, how many different permutations could I get from that? Well, I can get 6 different permutations, and the way I could do that is just by shuffling the numbers. So if I shuffle the numbers, I can get these permutations, right? Let me make sure I get all of them. Like that. So basically, that's what a permutation is. It's just a way of shuffling elements in a different order. So I'm going to show you a function that can do this, and it's pretty powerful. Let's check it out. All right, so how do you make a function that can return every permutation? First thing I'm going to do, like always, is just make a function. I'll call it permute, and let's console.log permute. I want it to have a initial array. Let's just say of A, B, and C. Those are the characters I want to find every permutation for, okay? And actually I should put this right here, and I should say, we'll call this the starting array, and then we need all the permutations that we want right here, okay? So I'm passing in A, B, and C, and then the permutations array is just going to be empty for now because I'm going to chop these elements and throw them into there in different order. So let's just return start just to make sure this works. If I run this code, I get A, B, and C. Cool. All right, so the strategy for this permute function is that it is a recursive function. A recursive function is just a function that calls itself until it doesn't. But more or less, I'm just going to call this permute function a bunch of times, and then I'm going to chop up these elements in different order and shoot them over here, and then print this out. So what I want to do first is have a base case. A base case establishes a parameter for when you should stop your recursive function. So I'm going to say when start.length equals 0, I want to stop doing this recursive function. Otherwise, it would run forever. So when start.length equals 0, I want to console.log my permutations array. This will give me the result of the permutations, right? If that's not the case, I want to do a for loop, and I'm just going to cycle through the length of the start array. So just know that when I chop up these pieces and put them in over here, eventually this start array is going to have a length of 0 because it'll be empty. So at that case, it's going to print out whatever combination of permutations I have over here. So what I want to do first in this for loop is basically make a duplicate of the start array. And the way you can do that in JavaScript is by using the spread operator, which is just 3 periods, and then I'll pass in start. This is really important because otherwise, if we were to modify the start array, it would screw up our for loop right here because we're going off the length of whatever is in the start array. And if you chopped off one element, for instance, now the length would just be -1. If you chopped off 2 elements, it would be -2. So you can see why that would be problematic. That's why we're making a duplicate. And then I want to actually remove an element at the dupe at index I. So the way I can do that is just make a variable called removed and say dupe dot splice I and then 1. So the splice method will actually mutate the dupe array. When I say mutate the dupe array, it's not going to return a new copy. It's literally going to modify the present dupe array. And then it's taking 2 arguments here, the splice method is. The first argument is the index you wish to modify. Well, I want to modify index 1, right? And then I want to remove just one element. Sorry, I want to modify index I. I'm going to say I. Whatever. Okay, but yeah, I go to index I and I want to remove just 1, okay? If I wanted to remove 2 elements, I would do 2. If I want to do 3, 3, just like that. So now that we've mutated the dupe array and we've removed 1 element, we want to paste that element to the permutations array. So we can do that with a simple permutations.push method and then pass in removed. So this is going to take whatever I chopped out of here. At the first time, it's going to be A, and it's just going to push to the permutations array, which is over here, and push will push it to the end of the array. So when I equals 0, I'm pushing A. When I equals 1, I'm going to push B. And then when I equals 2, I would push C, just like that. So you can see how that works. Let me undo that. So now that we've removed and pushed this new element over to our permutations array, we actually want to call permute again. But instead of using our starting array, we're going to use the dupe array. But remember, dupe has been modified. So I'm going to pass in dupe and I'm going to pass in permutations. So you got to understand this part. So when I first call this function, it looks like this. And then when I is equal to 1, we're going to chop off the first element at I, which is A, and we're going to paste it. And now we're coming down, we just pasted it right here, and then we just pasted it right here, and then we come down and we make another function call. So this, I'm actually calling the function again, but with B, C, and A, just like that. So what's going to happen now is this function has to run as well. So when this function runs, when I is equal to 0 on the for loop it's going to paste B right here. And then when I is equal to 1 on the for loop, it's going to paste C at the end right here. And then now the length of the starting array is 0, and it's going to print out that permutation, which in this case would be ABC. So I have a little image I'm going to show you in a second, but that's basically the breakdown. And to make sure our permutations array doesn't grow and screw up the other iterations of this permute function, I need to call pop. What that does is it just closes or just removes the last element of an array. So it's going to remove the last element on permutations because otherwise it will grow far too large and it would screw everything up. So that's all there is to it for the code. Let's print this out and see what happens. You can see I've got every permutation of those 3 elements in there. Let's make it a little bit cleaner. I'm going to use the flat method, which will get rid of these nested arrays inside of each other. Now if I run the code, you can see it a little bit better. And then I'm going to use .join to make it even cleaner. Let's try that. Okay, now you can see easily all the elements and their respective permutations, right? Let's try with numbers just to make sure this works. And it does still work. Okay, so I know this is a lot of talking, and it's kind of hard to wrap your head around this the first time you see it. I recommend using a whiteboard and drawing it out so you can understand the function calls, the recursive calls, because that's the confusing part, right? But in case you're still struggling, I'm gonna post the code in the YouTube video, and let's hop over to an image of what all these function calls actually look like. Okay, let's do that now. So here's a visual representation of all the recursive function calls. And notice we're doing that for loop, and then when I equals 0, we're going to grab 1 and put it over here. That's what this permute function, we're calling it like this now. When I equals 1, we're going to grab the 2 and put it over here in this permutations array. And that's why we get this function call. When I equals 2, we're going to get the 3 and grab that and put that in the permutations array. So basically from that initial array call, because we have 3 elements, we have 3 different recursive calls that are made because I is 3 different elements, right? From 0 to 2 is 3 elements. So now we have these 3 permutation recursive functions called, and they themselves are going to call the permute function again. So like, let's take this one, for instance. When I equals 0, we're going to grab the 2, right? And then we're going to put that over here. And now we're left with this type of formulation. When I equals 1, we're going to grab the 3. And then the 3 is going to go to the permutations array. And now we're left with this. Same thing over here. When I equals 0, we're going to grab the 1 and put it over there, which is right here. And then when I equals 1, we're going to grab the 3. So we have 2, 3 in the permutations array and 1 in the start array. So you can kind of see how these recursive calls are calling additional recursive calls. Notice down here, eventually we're going to have placed the item in all on the permutation side. And this start array dot length is now 0. And that's when we print out the actual permutation. And that is our result. So it's very hard to visualize this by just looking at the code, perhaps. That's why I'm saying, like, if you really want to understand this, I would recommend drawing it out on a whiteboard or some type of diagram like this, and then you can just walk through the steps. But just know that you're starting with that initial recursive call, and it spawns however many elements there are in your starting array, right? In this case, 3. So it spawns 3 additional recursive calls, and it looks like those additional 3 spawned an additional 2. So you have like a lot of recursive calls going on. But that is the permutations function in a nutshell. I hope you enjoyed the video and found it valuable. If you did, please hit the like and subscribe, and I will see you in the next one.